Yeah, so we're going to wade into streaming today. Talking about streaming in Python. My name is Elliot Cameron, and I'm a programmer. So, what is streaming? Streaming is a very general idea. Everyone sort of, with the advent of Netflix, everybody knows what streaming is, right? You stream on your TV all the time. Basically, it's this idea that I can start doing something useful without having all of the data. I have some of the data, but I can immediately start using it, right? And that's something we take for granted, actually. There's a lot of data out there that cannot be streamed. Can you think of any data that cannot be streamed? You can't use it until you have all of it.
Zip file.
Yeah, a lot of compression formats, yes, cannot be. Some of them can be streamed, but not all of them, yes. Good point. Any other things that cannot be streamed? Any ideas? What about a program? Can you stream a program? Can you run a program without having the program? All of the program? No, you
That's
can't.
what the machine learning says, like creating a program without through the data experience, without changing and impacting your.
Yeah, I mean, actually streaming is such a general idea that there are senses in which you can stream a program. That's what your processor does. Your processor doesn't have an entire program on the chip. It's actually streaming your program in one instruction at a time, or probably a lot more than that. So there is some level of streaming there, right? But so streaming is an abstract idea, but there's a lot of data formats that sort of as a data format don't support streaming. I have notes, but I can't see them anywhere. So I don't know what they are, but let's see. I don't know what I just did.
I think it's because you duplicated your screen instead of.
Yeah, I think that's what happened. Anyway, we will endure.
All right, aesthetics, who cares?
All right, yeah. So anyway, yeah. So not everything can be streamed, but a lot of things can be. Audio oftentimes can be streamed. Video can be streamed. I mean, people spend a lot of time writing algorithms for audio and video so that they can be streamed. You can get a lot better compression on video if you didn't stream it, but then you can't watch it until it's downloaded. So you give and take sometimes. So the idea of streaming is really important, and it comes into play a lot. I mean, if anyone who's doing like big data and analytics, it's really hard to load 4 billion records into your memory. So you want to be able to write algorithms that can work on parts of the data at a time instead of having to have it all. So because it's just a general idea, pretty much any algorithm you can write can be rated in terms of how well it streams various parts of data. But there's a very common pattern that you can use in Python to sort of get this idea of streaming. And it's called iterators. So what are iterators? Who would say that they have a good idea of what iterators are? And some, who would say, I know what iterators are definitely? Okay. Who would say, I have absolutely no idea what iterator is? Okay, so we're somewhere in the middle. Okay. It's a hazy fog, yeah. And so what's interesting is iterator is not a Python specific idea. Every language that I've ever used has iterators in it, and they're even called iterators. So this is a common idea in programming in general, and obviously Python has it too. But Python has particularly good support for it. I always said generators are my favorite feature of Python, and they are. We haven't gotten there yet. So the idea of, so let's just look at the word iteration. Right? What does iteration mean? Well, an iteration is a repetition of a process. So to do the same thing multiple times over and over. So a process that is streaming is often called an iterative process, or maybe an incremental. Incremental meaning one at a time, increment, plus one, plus one, plus one. And really, it's kind of like a loop. If you think about a loop, the whole point of a loop is to do the same thing many times, right? So iterators are very similar to loops. So here's an example of a loop. And these two pieces of code produce the exact same output. The left-hand side just prints this list of numbers, the right-hand side also prints the exact same output, but does not do it in one step. Obviously, the right-hand side is a lot more complicated, but as you can see, we manually stick the left bracket on there, and then we start with 1, and we loop while I is less than 4. We write the number, then the comma. You see what I'm saying? You see how it works? And then you increment the number, and you loop again. And then when you're at the second to last number, you print the last number in the last bracket. Okay, so it's a lot more work, but the advantage of the right-hand side is, well, the advantage of the left-hand side is a lot easier to read, and it's a lot simpler. And the advantage of the right-hand side is, what if you had a list that had 4 trillion elements in it? The left-hand side, does anyone know what would happen if you gave it 4 trillion elements to this list and you tried to run the left-hand side?
Out of memory.
It would run out of memory. It would not even run. It would just crash. And it would take up all your memory. What would happen to the right-hand side? Say again?
It'll run until the power goes out.
It'll run for a very, very long time, but it will not crash your computer. It'll run effectively forever, yes. But that's the advantage. One side, they both do the exact same thing, but one side will crash on very large numbers, and the other side will just keep going. Yes?
Sorry, can I quibble?
Yeah.
How would the right-hand side not crash? Because how would the left side crash? Are you assuming because you've loaded 4 trillion things into your process space?
Yes. I'm assuming that you actually have a list with 4 trillion elements in it.
But you would have the same thing on the right-hand side. If the data is what's causing it to crash, it's not the print statement that's causing it to crash.
True. So I guess.
Sorry, I told you I was going to quibble. Sorry.
No, that's fine. You're absolutely. That's a great point. So the idea would be if you had a list, if you actually had a list from 1 to, how do you even write 4 trillion? Whatever, a huge number, right? If you could generate that list, just the generation of that list at all would crash your computer, right?
Sure.
But the right-hand side is just the length of the list is, I don't have my slide anymore. The length of the list is encoded as this number.
Oh, because you're not representing all the data.
I'm not representing all the data. All I care is less than that number.
This is why I shouldn't quibble.
No, but it's a good point. This is the kind of thing everyone's probably thinking. Just to generate a list that long would take forever. But all this side cares about is how big is the number, right?
Thank you.
So that's the idea. And that's actually a key aspect of iteration, and that is not every algorithm has this property, that you could just switch between talking about the list and talking about the number, right? That's the difference between a non-iterative, like non-streamable algorithm and a streamable algorithm. This particular algorithm happens to be streamable, obviously. Right now, how do I get back to? Okay. So the idea of iteration is, for teaching purposes, it's very much like a loop. So what do loops have? The starting point, you start the loop. They have a current state, usually represented as I or something like that, right? For I in, so I is your current state. They have an iteration step, the thing you do, and they have an ending point, possibly. It might not ever end. So with that loop, we have a start. I starts at 1. We have an ending condition, where we loop until I is greater than 4. Here's the steps that we do every time, and then we have our current state, which is I, and we always update it every time, right? So that's the idea of iteration. So in Python, you can actually capture these 4 things: start, end, current state, and I forget the other one, in an object, right? Everyone knows what objects are. So you can actually create an object in Python that sort of represents these 4 things and gives you this idea of a loop, but as an object. So let me give you an example. Well, yeah. So let me give you an example. Here I'm going to translate this loop into an object that has similar properties. This is called my iterable. Wait, actually, you can actually see this Zoom thing? I am so sorry. I didn't even know that was on.
Look under more and see if you can minimize that.
Yeah, I'm sorry.
Just move it to the
Yeah,
top
you
of the
just shove
screen.
it all the way with the green one, right?
There's got to be a way to get.
Click on.
How do you get rid of this thing?
hit ID 741, would it let you keep dragging it up? You see what I'm talking about, the green?
Oh yeah, this.
Click there, and then we'll let you go in.
Doesn't let me get rid of this.
Once you Chrome view.
Say again?
Go to Chrome view in the full screen mode. Should be at the very top menu bar. Chrome view.
Oh, here?
No, the actual Chrome. Menu.
Oh, here.
Chrome view full screen. Oh.
There it is again. It's better. Thank you. Yeah. Whoops. I have no idea where I am now in my talk. Okay, so we're going to translate this. For some reason, I thought you couldn't see that. It's zoomed up. So we have every object has a constructor, double under init. And here we just set the current state to be 1. That's initial state. And then we have this special next magic method. And that is the key method to an iterator. Every iterator has to have this method. And obviously it takes self. And then we can do some things like, we have to translate this a little differently. But I can say, well, if I is 1, then I know I'm at the beginning, so I still need to print the opening bracket. But I can say, if I is, let's say, 4, I can do the iteration step. And then I modify myself. Don't worry about the return none for now. And then if I'm at the end, I print the last thing, and I raise this exception. This exception is very special. It's called stop iteration, and that basically says, I'm done now. Right? So this is how you translate a loop into an iterator object. Who has done this before? Maybe? Okay, yeah. So if you've done this, so there's actually one more requirement to an iterator, and that is it must have another method called dunder iter. And that, for an iterator, just returns self. It always returns self. So I did that by inheriting from abc.iterator, which kind of does that for you. Those are called abstract base classes. They're very useful. You can look at those if you like. So how this actually works, if you create an iterator, basically you're creating a loop. In order to drive the loop, to sort of kick it along down the road, you call next on it. And every time you call next, it sort of runs the next method, obviously, and moves the loop along. So next state, the first thing it does is prints the first, you see how it's printing each step on the left there, every time I call next. But iterators have special treatment in Python, and that is if you use them in a loop syntax, it automatically calls next for you. Right? So you can say for I in iterator, I don't actually do anything with the I right now, it prints the whole output. So iterator is a class instead of a loop that has the same result. There's also something called iterable, and basically that's any object that has just the iter method. I'll get into this a little bit later, but all iterators are iterables, or subclasses, and I'll get into the difference a little later, but a classic example would be a list or something. But basically this is an iterable. It's a different class that you can't call next on it, but you can get an iterator from it. I'll talk about this more later. Yeah, I guess that's my point. You can't call next on an iterable, but you can still use it in the for loop, because for loops automatically call iter before they start running next. And this is why you can use lists in a for loop. All right. Yeah. So you have to start with calling iter on the iterable. So first you have an iterable. Calling iter on the iterable gives you an iterator. And then the iterator is the thing you call next on. So the key distinction here is that iterables don't have this internal looping state. You sort of initialize the looping state by calling iter, and then next moves it along. We're going to do a lot of examples, and that's really what I think these things will start to click if you're not used to this. But here's the question: why would you want to do this? Obviously, if you look at the code examples, the iterator is a lot more code, and it's actually harder to read than the loop by quite a lot. It's actually harder to write too. So why would you want this?
Ooh, I got it. Go stream Netflix.
Yes.
All right.
You guys can go now. Why would you want this? Well, one is,
we getting something and processing, and then we again iterating, then we processing, then iterating, and better memory usage, because if we go in a loop and all, everything will be in a one shot. But in iteration, it will use only one run at a time data. The memory usage will be better.
okay, so less memory, is that why?
The memory usage also, are like you said, in stream, so we can process data at a time.
One at a time, yeah. Is that what you're saying? Yeah. But why would you use an iterator object instead of writing a loop manually?
Because you don't know how big the set that you're going to move to.
That's maybe a reason. Okay, it's an abstraction, that's a good key, yeah?
Where was this key thing? You have to map it in the function and see it around.
That's the key, yeah, I think these are the keys here. Remind me what your point was?
Abstraction.
Yeah, okay, so it's abstraction and it's an expression. Those are the two key points. First, it's an abstraction, which means you can talk about more than just loops. You can talk about a lot of things that aren't just loops. And you can actually translate things that may not actually be loops into things that look like loops. And the other one is, it's an expression, which means you can pick it up and hand it to somebody. Can you pick up a for loop? No, it's a statement. You can't. When I say pick up, I mean like number 5 in Python. You can say x equals 5, right? And you can hand it around. You can't say x equals 4. You can't do that in Python. But you can say x equals my iterator. So you can create these iterators and pass them around to people, which makes them first class, which makes them composable. And that is the real abstraction and composition of the two biggest powers to iterators.
So you're saying you can do loop-like things outside of loops?
Yes. Yep. And you can build loops out of smaller loops. Because with for loops, you can't really do that. If you want to, you can, but it's a lot more annoying. Okay. Wait, okay, now opening iterator, yeah. So, I'm going to talk about how to compose iterators. I'm just going to show you some iterators that I wrote late last night. So here's the iterator we talked about. So this is the iterator. Now again, this thing's in my way. Can you guys read this? Is this too small?
That's all right. It's fine.
Okay. So here is this. This is the exact same iterator I showed you. And this is the full body of the iterator, which is fine. This works. But it would be pretty cool if we could make this out of smaller pieces. Like, what if there were what if there's a library that just gives us a bunch of iterator tools, like building blocks, and we could build our iterator out of that? So here's one example of a building block. Standard out. Who does not know what standard out is?
I would love a refresher on what standard out is.
Okay, so standard out is, have you ever used the terminal console app? Standard out is literally just what comes out when you after a command. That's called standard out. So when you type echo type, it shoves the word type into the standard out. So you can do a lot. You can do more things like cat means open a file and read it to me. So I just opened this file and here's all the contents of it, right? So it just opened a file and shoved all the lines to standard out. So that's what standard out is. So we can actually write an iterator. So notice in our original one, we're manually writing the standard out, stdout.write. We can write an iterator that only does that. That's all it does. And what's interesting is, it's actually an iterator that takes an iterator as an input. It has a before, an after, and then it takes an iterator. And what it does is, I don't want to spend too much time on this because we're going to just write it better later, but the idea is it starts by writing the out, and then it erases that, and then it, every time you call next, it writes something to standard out. It doesn't matter what it is, and at the very end, it writes the end. So this is sort of just the standard out piece of our iterator above, and then we can write a different iterator, which generates a range of numbers from 0 to whatever you want. Begin, end, this is pretty easy. This is basically just like a loop where you add +1 every time. So current +1 every time you write next. So 1, 2, 3, 4, 5, 6, and when you get to end, you raise the stop iteration. So what if you could? It's the wrong file.
It's always better when people are watching.
Yeah. This is.
Can we do reverse of iteration like we can do reverse in list and all?
That's a great question. Can you do reverse on iterators?
I just asked like
Well,
previous and all.
So the answer is yes, of course you can do reverse, but what does it do? What does it effectively do? Does anyone know? What's that?
It's the same thing.
Same thing as doing on list, you mean? Yeah, the output is the same, but what does it do if you revert?
You have to have a previous.
So it probably consumes the function? No.
Yeah, what would you say?
Yeah,
Yeah, you have to consume the entire list because you have to wait to the end, and then you can print them backwards, which means you have to build up the entire list anyway. So yeah, running reverse on iterators, silly. It undoes the iteration effectively. This is hilarious how this worked 7 hours ago and doesn't work right now because I'm in a talk. Let's see here. Am I in the right? Oh, maybe I just bought it wrong. That never happens. Okay. All right, so I think, yeah, there we go. So here's the two iterators I just showed you, std out and range. And if I do like a loop on those and print I, then I have no idea why it did that, but anyway, you can see that it sort of kind of works, but doesn't. Doesn't matter, because we're going to do this better anyway. Obviously it doesn't, oh that's right, this is not supposed to work. This obviously doesn't have commas because I didn't do that, so you can write an iterator that literally intersperses something in between everything else. This is extremely complicated. It took me way too long to write this. Don't worry about it. The point is you can do it. So, for I in this series of iterators, obviously that doesn't work. Don't worry. We're going to write it better anyway. But part of it, this is one of those things like if we're taking math and like they teach you the hard way and they're like, and now we're going to teach you the easy way. Like, why did you teach me the hard way? Obviously this was working at some point, but I must have botched it. So the point is you can compose iterators. You can build little iterators. So here's, at once we had one giant iterator, but now we have 3 small iterators. Right? They do 3 separate things. One that just counts from 1 to 5, one that intersperses commas, and one that streams everything to standard out. So it's composable. It can build with pieces. And hopefully my next examples will actually work. But what's really cool is that was a lot of code to write all that, but Python, this is one of my favorite features of Python, actually has built-in syntactic sugar for writing these a lot more nicely. And that's called generator. So generators is built-in Python syntax to give you iterators, but without writing these big, giant objects. So here is an iterator on the left, a generator on the left that does the same thing as our range iterator. So here's the object. On the right we have the object version. On the left we have a generator. They do the exact same thing. They're both Python. On the right we have these methods and stuff. On the left you can see we have this interesting keyword yield. You see that keyword yield? Who has never used the keyword yield before? Okay, so yeah. Basically what happens is we start this thing, we say I equals the beginning, while I equals the end. This is very similar to the loop we saw before, but instead of like printing or doing something else, we yield. And what that means, basically generators let you do is say, yield effectively is this next method. And it basically yields control back to the person who's using this iterator, and they can do whatever they want. And then when they call next, it starts at yield and resumes the loop. It's very kind of trippy if you've not really worked with it before. But as you work with it, you kind of get the hang of it. So this is a much nicer syntax for the exact same thing. Let's just start with questions on this. For whom does this generator make sense right now? It makes perfect sense. We get it. Okay, like 3 people. Okay. So obviously we need to talk about this. It makes sense to you?
No, it always breaks my brain. What does the call stack do?
Good question. So, generators break the idea of a call stack, and that's why they're trippy.
Okay.
They're actually a simpler idea of something that's called a coroutine. And coroutines are what are called stackless. You don't have a stack. Because you're absolutely right. You're used to doing return there, and return is the only way to sort of exit out of a function and give control back to the caller. But every time you call return, if you want to get back into the function, you have to start at the beginning again, right? The thing with yield is it's like return, except when you come back into the function, you get to start where you left off. So
when I call range gen a second time, it starts at I + = 1?
not when you call range gen a second time, when you call next. So let me just run this.
So you returned it. Well, what did you return? Is that an integer?
So, yes. It's an integer, yeah. So let's
state in there somewhere.
run it. Range gen 1, 5. So this is interesting. What range gen 1 to 5 actually returns by itself is a generator, which is basically just an iterator. So it's an object.
Oh, so yield throws a little extra state in the return to make it a generator?
Yes.
Oh,
If you use yield in the function, that whole thing becomes a generator, which means when you call it, you don't get a number back or anything, you get a generator back.
Okay.
Which is basically this object which represents a series of states over time, right? And every time you call next, let's say x equals range, next x1, next 2.
Okay.
See? What?
Next to X.
Yeah.
So 3. That was weird. I keep doing that. I'm expecting 4. You have to have the same thing. And then you write areas of stop iteration. So it's just like what you would do with an iterator, right? It's just that Python gives you this like much nicer
So hold on. So when it fell out of the loop, it automatically returns stop iteration.
Yes. When it fell out of the loop, the generator automatically raises stop iteration. So that's why I say it's syntactic sugar. What that usually means is Python translates this syntax into the object we wrote before. It can automatically make that translation for you without you having to write the code.
Can you yield the tuples and things?
Yeah, you can do anything you want.
Okay.
Yeah, you can. This I can just be.
I comma 3.
It doesn't matter. Yeah, if we did this, it would just yield high 5 times. But see, once we get to the stop iteration, we can't hit next anymore. Like this x is exhausted. We've used it up. If we want another one, we can just call range in again, and now it starts over.
So it's like you're taking a snapshot of the state each
Yes,
day.
which is why it breaks the idea of the stack frame, because it remembers it remembers the values of all the variables in your function, saves them, sort of saves them, and then when you call next, it gets them back and starts from where you are. So yeah, it's different than call stack. Yeah.
So you could achieve the same thing with an iterator if you plug in on list 1 to 5, and then you would have exactly what you're getting out of range gen, right?
Yeah. You can do the same thing. Yeah.
So why do you want to have? Why does a generator exist?
You could do stuff like with a Fibonacci sequence, right? It doesn't have to be just a linear go down a list thing. You might actually be computing something rather than just plus equals 1.
So it can come out of an algorithm instead of something that has to exist somewhere in memory anyway.
Yeah, one of the really nice things.
Right, that was my big oopsie in the first question. I'm like, you don't have to have all the data resident in memory. You're just computing the next one and then throwing away the last one. And so you can go through an infinite sequence of computation and still take up order 1 memory rather than order n.
So then that leads me to the next question, which is, if that's what a generator does and an iterator does not do that, does not calculate the next value on the fly, then where does an iterator save you anything on the iterator side?
Iterators do calculate the next thing on the fly.
They do.
They just, so this next method, they just do it more explicitly. Like with the range, see the range object on the right? When we call next, it's no wonder it calls the next method, and it's looking at its current state. If self.current is greater than end, then stop. Otherwise, self.current plus equals 1. So it just calculates the next one.
Okay.
And then it returns -1 because I calculated the next one, so I need to give you the current one, which is one less than that. But that's another reason that these objects are a lot harder. They're just a lot harder to write because I have to write these if statements. Because I've got to like think about where am I in the loop. Whereas the generator lets you stop thinking about where you are in the loop because it remembers for you.
So there's a difference in just syntax?
Yeah, it's just syntax. You can always write anything in either form.
Okay.
And it's just that Python, one of Python's big mantras is easy to read, right? This is not easy to read.
Yep, you can use generator, comprehension syntax like those as well. So it's just like, you know.
Actually, we're going to get, that's my next point. So,
yeah.
great point. Great points. Your point is we can do even better than that. Generators have even nicer syntax for certain types of transformations. If you're doing anything that's a map or a filter, you can use a generator comprehension. Thanks for bringing that up. This does start to break Python's idea that there's only one right way, obviously, way to do things, but so here is what. So I've written the exact same thing in both forms. So the top one is a generator that takes an iterator. I hope that isn't too confusing. Basically, iterators are basically like lists, but they're not all there in memory at the same time. So it takes some sequence of items, and it just doubles all of the items and throws away odd numbers, doubled evens. So for I and int, if it's divisible by 2, then yield I times 2, so it doubles it. But we can write the exact same thing down here, which is interesting. I'm actually introducing two ideas in the same slide. This piece in parentheses, ignore yield from for a second. The thing in parentheses is called a generator expression, and it lets you write the exact same thing as above, but as one line. Has anyone ever used list comprehensions? Okay, so this is exactly the same thing as list comprehension, but with parentheses.
I would say you're like veering into Perl territory.
Yeah, this is getting a little too concise for Python. But so this expression on the right, you can use that anywhere. If you want to pass, like, I've got this list of names, and I want, well, that's not a good example. I've got this list of numbers, and I want to throw out some of them before I pass it to the argument. Well, you can just, instead of passing the list, you just pass I for I in list if, and it throws out the ones you don't want. Very, very concise. So yield from is another thing that I'm introducing here, which is just an extra little syntax that Python also has for generators. And all it does is let you, I'm just going to write down what it does. Here's what it does. Def it my gen. If you say yield from something like this, which works, that's exactly the same as writing this. It just,
I like that.
instead of making you loop manually and yield everything in the loop, it lets you just say yield from all the things in this thing. Right? So it'll go through that list at the top first, whereas you could have written that manually down at the bottom. So yeah, Python is going really hard into this syntax sugar world where it's trying to make it really concise for you.
Larry Wall is saying I was right.
Yes, more. Yeah, yield from seems like a little bit of a push in terms of like, it only saves you one line. That's it. But
It's pretty.
it's pretty.
Yeah, at least when Python's doing it like a slightly different way, it's actually like the same way.
Yeah, it's
Right.
it's very the same. The magic is very minimal.
Yeah.
Slippery slope.
So yeah, if you've never heard of list comprehensions, then a list comprehension is just the same thing as a generator comprehension, except you use brackets. So let's say I for I in. I always use range if I. So this is going to show us even
Forgot
numbers.
something there before we were in.
The only difference between this and the generator is that this
Can I ask you
actually.
a dumb question about the syntax? What is the relationship with the 3 i's in there? Are they all the same I?
Yes.
Somebody said yes.
So one of them is a binder, and the other ones are actual. So you can translate this mentally into a regular loop. Imagine if for some reason, like somehow you could return from a loop, like every time. This is what it translates to. Like this is made up. Sometimes you can't actually do that. But for all the i's in range, if I is not divisible by 2, then return it. But this return, it's a made up return.
Well, your last line would be appending I to a list.
Yeah, there we go. It append, list that append I. Exactly. Thank you. This is what it is.
So that first I, so on line 20, the first I is the append I.
Yes.
Okay.
Well observed. Yes. And the second I is really the second, like after the 4. That's how you can like move that down into the beginning of the line. Yeah. Similar to how if you do inline ifs in Python, like 5 if true else 3. It kind of like reorders the if. Normally you would put the true case after the if, but for some reason they flipped it around.
So all snarky joking aside, how do people typically write this stuff? Do they write it in this 1-line form, or do they write out the 2 or 3-line form? Like what is more Pythonic?
I'm the last person you should be asking about that.
Okay. Does anybody know?
I like them if you're just doing something simple, you can say print I for I and I, or something like that, or print I for I in a list of something, and then you could add on if something else, and then that would be like 1 line as opposed to, because you're saying print I for I in some list if I modulus 2 equals 0 or something. If you did that the normal way, you'd say for I in the things, colon, enter, indented, if I modulo 2 equals 0, whatever, colon, again, enter, indents, then you print I, as opposed to just saying print I for.
No, I get that it would be 1 line versus say 3, but I'm saying that the whole mantra of write simple and clear. What do people actually find the 1 line more clear?
I do, because it sounds like you'd actually say it. Like if I'm speaking to somebody, I'd be like, go to the store and get this if this is the case.
Yeah.
Otherwise, it'd be weird if I talked to you and I was like, so if you're going to the store, and this happens to be the case.
Yeah.
I think it also depends on how much you're doing in that 1 line.
And the other thing is you don't have to name the 1-line generators. So if you want to use the yield statement, it has to be inside of def. So if all you want to do is like filter out evens, or odds, if that's all you want to do, you have to write like no odds and write that out. It's a lot. It's actually if you had to write it out like that, you may not even bother to do it.
Okay.
Like the syntactic overhead of having to name the thing is too much work. But because you can just say, because you can just do that,
Right.
Yeah, and you
Like,
don't have
cool.
to nest, so it's more by going away.
So,
And like, if you-
yeah, so seriously, not trying to be snarky, this is exactly how Perl started, right? And ended up in the total mess that it's in. And I know probably nobody in this room knows Perl at all.
I don't know
but
Perl. I've only heard endless stories about Perl.
It is, you could, some of the code is just an absolute atrocity to try and read and grok.
So one of the things, I had a teacher who taught me about list comprehensions, and he compared them to SQL select statements, and he even suggested you write them on multi-lines, so you have the I for I on the first
See it
line,
that way.
and then you put the N underneath that, and then the if underneath that, and it's kind of like select your I from the range, and then the if is like your where clause in the SQL statement.
Okay.
And the nice thing about Python is it allows you to write it that way, so you can make it more readable. You don't have to try to fit it all in one line like that.
Yeah, you can imagine yourself doing something like that. This is basically select. Select name, age, and gender from all the rows within this.
Okay.
Here's your where clause,
Dictionaries too.
right? Here's your where clause. And oh, that builds up the entire list of memory. Fear not. I will convert these brackets into parentheses. Right? So, yeah, it's very much like, we can't do like joins and group bys and stuff, but you can do the average stuff.
Okay.
So, yeah, so generators can only do two things, filtering, if, and mapping, which is, you can do something other than return I, you can return I times 2, or I divided by 2, or whatever you want. So it lets you map a new value for every row. Okay. So, like I said, sort of to your earlier point, generators are part of this idea of what's called a coroutine because they don't have a traditional stack frame. You can actually so yield lets you push data out of a generator. You can actually, the receiver can actually push data into a generator as well. It's not a very commonly used feature, but generators actually have a send method as well. I haven't really found a use for it other than modeling monads in my Python, but actually the new async await stuff is sort of based on this idea.
What are you referring to there?
Are you familiar with async await? And okay, so that's a topic for another talk. I was like tempted to go into it, but that just talk would have been like 8 hours long. Async await lets you have basically do multi-threading in Python, sort of, but interwoven on one thread. So it's sort of how, JavaScript, that's how JavaScript works, that's how Go routines work, that's how Haskell screen threads work. It's becoming a thing now to have these sort of interwoven threads, and Python recently got it in Python 3.6.
Okay.
Well, anyway, it's a newer feature. And it's very much based on the sort of precursor idea of generators, coroutines, which were actually introduced in Python 2.5. So they've been around forever. People just haven't used them that much. Another random note. Generators can be recursive. Generators can call themselves, but they're just like normal Python recursion. Eventually, you'll run out of stack space, and it'll blow the stack, so you shouldn't do that. There is a magic trick, though, that no one I have ever seen use, and because I was really curious, I spent way too much time last night trying to figure it out. You can actually write recursive generators using something very magical. And if you want to know about that, it's about 7. It's way too advanced for this talk, but we can talk about it after if you're really interested. Yeah, generators are extremely powerful, and I can't even get into all the uses. People use them for lots of things besides iteration. People use them for content, like writing really easy context managers. You can use them for writing trampolines. So, I don't know how much time we have left, but I didn't know how many people would be here and where we would all be at, so I thought maybe we would build some examples, and that way you guys can help me figure out what to focus on, what would help you get the hang of this stuff. So, I have some ideas of what we could build. I was thinking we could build some like basic Unix tools, like, anyone of you ever used grep?
Yes.
Yeah. Who has not used grep? Oh, everyone's used grep. Great. We could write grep. And what's great about Unix tools is that they work on standard in and standard out. And if you want to grep through an enormous file, like a 7 GB file, it will work. Because it doesn't load the whole file in memory. It just loads one line at a time. So we can get that same behavior in Python. It's very few lines of code. So we could write grep, for example. We could write cat. Who has used head? You know what head does?
Top line.
Say again?
It's starting line, top of the.
Yeah, it gets you the top of a file. So maybe the file's 7 GB long, but you just want the top of it. Let's say, I think you can do minus n like 5. Let's do what? That's the best kind of 3.
You're gonna put in first.
Yeah. So head minus n3 gives you the top 3 lines of a file. It doesn't load the whole file memory. It literally just does the first 3 lines. And then tail does the last 3 lines. Well, whatever you want. So this is interesting because it still has to traverse. Well, tail's probably smarter than that, but it still has to get to the end somehow. But what it can do is throw away any amount of information. So anyway, we could write these apps. Would that be helpful? We want to try to write some of these things and get the hang of generators. Sound good?
Let's do it.
All right.
When you say grep, I assume you mean fgrep without all the expressions and stuff, right?
I mean, we can use regular expressions, but
Okay.
I mean, Python has a really nice regular expressions library. So maybe we'll start with, so grep is basically the same as just cat. Cat just prints the file out. But grep only prints lines that match a particular expression, right? So maybe we should start with cat, because all it does is read a line, write a line, read a line, write a line. That's a lot simpler. So I'm going to open Note to Zoom. Please let me get rid of that thing. So let's open a file here. And what we're going to do is, and another reason, a great reason to do some examples is because there's actually a bunch of iterator tools already available in the standard library, which you can use, which are super nice. And we'll get to use some of them. So let's start out with, the obligatory if main run our main function. And we need to be able to parse system arguments, so we have to do this. Sys.arg, we don't care about the first one, 0, so we're going to do that. We haven't written main yet, so let's write main. All right, and this currently does nothing. There's our shell of the program. Make sense to everybody? Mm-hmm. Okay, and let's see. We first want to write cat, right? So what we can do is for line in standard in, actually it's going to be sys.standard in. Sys.standard out line. That's pretty easy. This is just a loop, right? We haven't really gotten to iterators yet. Let's see if this works. Okay, so it's waiting for me to type something. Oh, it didn't work. Let's see why not. It's just,
It should be on.
not right. All right, actually, I think I have my enabled, which may have told me that. Yes, it would have told me that. By the way, use MyPy. It's amazing.
What is that?
It's called MyPy. It's like DerbyPy. Basically, it'll do some level of type checking on your Python, and if you have this extension, it'll do it live while you're coding, which is super nice. Look at that. It tells me that there's an error in my code before I even ran it. Oh, now it's fine.
No, I'm sorry. I meant, what does the arrow none do?
Oh, I'm sorry. This means this function returns none.
Oh.
Because obviously I didn't return, if you don't return anything, it returns none by default. And MyPy only checks functions that have some sort of signature on them. So if you don't write a signature, it just won't check it. And if you write a signature, it'll go, oh, I guess you mean for me to check that, so I will. So Python talk, so this is going to do nothing until I type. Aha, look at that. I typed hi and it printed hi.
Wow.
And what's cool is we know this is working iteratively. Well, this is a regular loop, right? This is fine. Standard in is actually an iterator. But we know this is working iteratively because otherwise, if this was a list, actually we can make this stop working. I believe if we do this, it'll stop working like that. So if you turn an iterator into a list, it tries to eat up all the things and then give them to you all at once. So if you call a list on an iterator, that's what it'll do. I believe here, see, it doesn't print out.
What if you hit Control-D, it will?
Exactly. Well observed. So that does, it prints them all out at the end, which is fine unless that file is really big, right? So that's sort of the difference. Streaming lets us work with them one line at a time, whereas turning it into a list makes us work in the whole file at a time. So with a very simple change, we can get different behaviors. So this is our standard loop version. I want to write this as an iterator, just to like prove it as maybe a generator. So let's see, I had some like pre-written versions of this. Cat actually has like a lot more advanced behavior on how like you can cat multiple files. So maybe that's worth doing. Just a second. Okay. Yes, I'm actually just gonna. Then I wouldn't be able to teach you about chain from interval. So that's a little. I feel like that's a little too advanced right now. All right. So let's write. Let's break this down just for fun. Okay, so we're going to write a generator that just consumes some iterator. Actually, no, you know what? We're just going to go with this. Now, let's say we wanted to use a generator to do basically build grep. Right? What does grep do? Grep filters if it matches an expression, right? So let's import regular expression. And now we have the first argument to grep is the regular expression. So like anything, not anything, or something like that. Anything that starts with, that has the word hi in it. So let's take the search term and then args. Let's use keywords. And then what we can do is this. Our regex is going to be re.compile. We have to compile the regexes. We're going to compile the search term, and then I'm actually going to put a generator right in line, right here. Everything, so this says for all the x's in centered in, give me x's back if the regex matches the x. So now let's say Python talk. What should we search for? Has the number 3 in it. Did not print. Did not print. Did print. Did not print. See that? Now we can pipe things like cat. I don't think we have the number 3 anywhere. Let's see. Cat talk.py to this. Let's search for
Right.
Pretty cool. And we did that in effectively 3 lines of code. All this other stuff is just kind of like boilerplate you have to do.
Could you do, so on line 6, could you just do sys.standard out that right, And the generator?
Yes, you can. You can do that. That's great. This is what I was hoping for people to come up with ideas. You can do this. You can do just this. And then your loop is basically, you're not actually using the result, so it's just pass. But yeah, you can totally do this as well. What did I just do? Oh yeah, it got moved, of course.
Change to
So I actually have a function for this. I call it exhaust. And now you can just write exhaust the iterator. Oh. Why does it hate me? Oh, I've got my friends. So now our, if this was in a library, let's say it was in a library, then our code becomes 2 lines. Oops, that's not what I wanted. Pretty awesome, huh? We put grep in 2 lines. Two meaningful lines that aren't like boilerplate. Cool. So that's grep. Maybe we can write. Who has used yes? Does anyone know what yes does? Yes just prints y forever, unless you pass it an argument. Yes, no. But it just prints that forever and ever and ever. Why would you want that? Well, because maybe you have a command that asks, like, do you want to do this? Do you want to do that? Like, yes. Yes to all of the things. So you can be like, yes, pipe, delete files. I mean, I want you to delete all of them. Okay? So we can write that really easily. Oops. So the thing you want to arg is the thing you want to say over and over and over. What's interesting here is we can actually we can write a custom exhaust function that's for standard out. And it's just exhaust standard out x for x and it. Right? And now I can just do that. So this is the cool thing about generators and iterators in general, is that you can sort of start to pull you're basically creating processing pipelines, right? You can make hundreds of these things and you can piece them together and then some guy can just stick all the pieces and create like flow pipelines. We're basically doing big data processing already. Now we're just going to write to standard out. This is going to be interesting. We want to print arg forever. How would we print it forever? Well, you could write while true. We all know that. Can you do it with iterators? This is where I want to talk about iter tools. There's actually a function in this. There's a module called iter tools. I highly recommend it. What is this? Oh, there's my notes. Wish I had notes. There's a bunch of cool functions in iter tools. You just search the built-in documentation. Iter tools import cycle. So what cycle does, it returns elements from interval until. Oh no, that's not what I want. Repeat is what I want. That cycle is also useful. Repeat. Repeat an object n times or forever. So I can say to standard out, repeat arg. I believe that's it. Wait, this is not going to do the right thing. I want to say.
It needs to be arg if arg is not none, right?
Oh yeah, I need a default, don't I? Repeat arg if arg else y, right? If you don't give me an argument, I'll default to the yes. Actually, this is a list, isn't it? So it's going to be arg0. So I can do. Let's make it so we can. This should be called grep.
Is arg always going to be?
Are you familiar with?
Is 13 always going to be true? Do you need to say arg0 if arg0?
If on lists will only be true if it has at least one element.
Okay.
So we can say main. Let's see. Let's do this. Program args And then we can say if program equals grep, then we will run grep on the args. Otherwise, program equals yes, run yes on the args. So, reasonable? So now we'll have to write grep or yes here. So let's do yes. Let's just see what happens. Didn't work. Why? That's interesting. 110. Doesn't like my. Oh, must be string, not tuple. Oh, I gave it a tuple, interestingly. Clearly, I need MyPy. Help me. MyPy, help! MyPy is actually really powerful, but it's not helping me right now. Let's see, X, where are we? We're in yes. Let's just make sure we're in yes. Okay, it is getting here. I wonder if... Let's see. Let's try this and just see, like, make sure we're P's. P arg 0 if arg. So let's just get rid of this for now and see what happens. Okay. Oh, that's interesting. Standard out is not printing a new line, so I need to add it myself. So there's something weird with these args. I'm not sure what it is. I don't necessarily want to think about it for everybody. Oh, I know why. Sorry. There we go. So we should do this. Arg 0 if arg else. And we need to always add a new line at the end. I know, we can just make to standard out, take an extra argument. Okay, that works. That works. Cool. So we wrote yes. And this is obviously something that has to use iterators because it goes on forever. This can't. I mean, it gives a loop too, but that's, we're forcing ourselves to use iterators here.
That's a fair question.
Yeah.
So it's not exactly yes, because when you hit Control-C, you get a Python stack trace out. How would you suppress that Python stack trace?
Yeah.
Or is that, if that's too much to answer right now?
No, it's a keyboard interrupt, right? So I think we can do...
Well, if you just wrap it in a try.
I believe so, yeah.
Oh, that's lovely.
Whoops. Wrong language. We just end here. I believe that's all I have to do. Yeah. So, yeah. So we've written yes. Let's see, any other? I had some ideas written down here. I wrote them all just for fun. T is a real fun one. Does anyone know what T does?
It sends the standard out and writes the file.
Yeah, so let's use, and multiple files even if you want. So T is interesting. It's actually really not that interesting when in Python. It's pretty, you just loop over all the files and write to them. There is, however, it's worth mentioning that, there is a T function in the iterators. This is really cool. What you can do with T is, let's open this file up. That's funny. What you can do with T is if you have the iterator, like let's say range 10. Range, by the way, range, have you used range? Anyone know range? Yeah. So range is also an iterator. It doesn't actually create a list, is the point. So that's built. That's just built in standard library. What were we talking about? T. Oh, yeah, that's right. If you had an iterator and you wanted to like create two iterators out of it and traverse them separately, that's what T would do. You can have T create two different iterators from one iterator. What? Oh. Yeah, so now, if you call next A, you get 0. If you call next A again, you get 1. If you call next B, you get 0 again. Because they're two separate iterators. And what it does, it's really tricky, because the input is also an iterator. It creates a buffer, which represents the distance between the two iterators. So it has to sometimes build the buffer up, because one iterator might be way ahead of another. But it basically only keeps in memory as much as the difference between the two iterators is. So you can kind of, as long as you traverse them sort of in step or close to it, you'll use a very little bit amount of memory. So this can be a huge, this can be like an infinite list here.
Well, I'm sorry, I didn't quite rock that. So it made 2 copies of the iterator?
Yeah, but T is kind of, it's a little trippy. What it's doing is, so normally range, if you call, let's say you have x equals ranged, right? Every time you call next on x, you get the, this is right. Every time you call next on x, you get the next one, right? You can't, do that every time. You can't go back. You can't go back in time. You can't figure out what the previous one was. Now you've already you ate it. It's gone. T, but let's say you wanted to loop over x in 2 different loops. You can't really do that because the next of one loop will eat things up, and the next. So instead of like working in parallel, they'll just end up sort of boosting each other along.
So you're keeping a window in the iterator, so to speak, rather than having 2 iterators?
Yes.
That's good.
It actually uses the same input iterator and creates this like window, which lets you traverse both of them separately.
Because the Unix command, I don't think of T as that operation.
Yeah, it is a little interesting. It's basically like you take one input standard in and split it between 2 outputs.
So is that just for instructional purposes, or would you want to do that for some reason?
I actually have an example of doing that.
I'm ready.
No, you're not. It's incredibly trippy. It's actually the magic I was talking about. If you want to learn more, that's where I use it. Not because T is magic, but because I need to use it in my magic. But we can come back to T. Maybe some simpler ones. Here's a built-in one, filter. Now, this is really just, so filter is a function which lets you use lambda or something, x mod 2 equals 0. This gives you an iterator. We talked about this in the last talk, but this is just like a generator comprehension, except that it lets you use the filter lets you use mapping a function instead. I don't know why you use filter instead of just writing your generator expression differently. Using the x for x in if. I don't know why you would use filter instead, but it can have uses. Map is another one, lets you do the mapping. But and it's also worth just remembering that list always consumes all the elements. So if you have a generator, so what do you think is going to happen if I do this? Boom! And it's never going to finish. Oh dear. Okay. I think I would sort of hope that Python
Eventually it'll crash.
had better handling for, oh dear. I can't even open.
Yeah, that happened to me earlier.
Oh
Just gonna have
dear.
to wait.
Oh dear. we have to pull out the big guns. And that is even not working. Maybe it's, I bet you it's not finding me. It's this guy.
Isn't the garbage bin right now?
My computer's heating up, I can feel it. Oh dear. There we go. Probably ran out of memory before I got to it. Okay. AKA, don't do that. Oh man, how to blow up your computer. So yeah, so cycle is a really cool one. So cycle basically does the same thing as repeat, but it lets you sort of do a list that repeats over and over. So let's do 1, 2, 3. This will create a cycle: 1, 2, 3, 1, 2, 3, 1, 2, 3.
Question.
Yeah.
Are there use cases where iterators do not make sense and an actual loop, or how you might use it normally?
There is, I cannot think of any place where you would not be able to use an iterator instead of a loop. They are loops.
Right, but
Just
are
for different
they,
syntax.
that's what I'm saying, like more sense, like you
For
can do
syntax?
both, but I don't know.
Well, like here's an, we talked this exhaust function is a little odd, like it's just kind of weird. Like it loops through the iterator and does nothing. So that assumes that your iterator actually doesn't return a result and does something with the item instead. That's a little weird. In this case, probably using like a for loop instead of exhaust actually makes more sense. Just syntactically.
Is it expected that iterators are not supposed to have side effects?
No, definitely not expected. Although they are not, they usually are expected to have a result. Whereas see how this one doesn't. Actually, the result of this iterator is none, 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 none. It's none 1,000 times because this write method returns none. So it's not. This would be. I would say this is probably not very common for you to have an iterator that like does standard output right. Although I find it just looks fine to me. But I can imagine a Pythonista going, what? No, that's kind of weird. Just put it in a loop. It's one extra line. But I can abstract it this way. So it's worth just browsing some of the iter tools. How do I open my? Oh, that's why. Yeah, you guys have asked lots of questions. That's good. I don't. I'm like losing the ability to use my computer here. So iter tools. Yeah, there's a lot of really cool ones in here, and we'll So count. This just loops 1, 2, 3, 4, 5 forever. Cycle repeats the pattern. Repeats the same element over and over again. And then there's some other really cool ones, like accumulate chain. Chain is probably worth talking about briefly. Chain lets you take multiple inputs and like chain them together. So you could write something like this. A, B, yield from A, yield from B. And now you can do chain range 10. Oh dear, cannot type. Oh, my computer's like, literally cannot type. There you go. So this takes 2 iterables and iterates through one and iterates through the other. That's what chain does. If you import so this is let's see, iterators.chain. Actually, you have to call it from iterable. Oh no, this is actually fine. Yeah, same thing. If you have an iterator of iterators, you can do this. That means you can have iterators of iterators. Iterators that produce iterators as their item. And then you can chain all those together. So this is, I have an example of how you would write like a real version of cat, because cat lets you iterate over multiple files. It's basically, cat is basically chain. It's the exact same thing. It lets you take 5 files and it will write them all out in sequence. And one of them can be standard in. Actually, multiple of them can be standard in. So my version of cat that I spent more time writing basically lets you do this. You open all the files, and then you chain from iterable all of the X for X and X is for X and handles. Yes. This is just creating an interval of all the lines. Anyway, yeah. So this lets you do kind of what cat is doing. What are some other fun ones? Take while. Oh, so iSlice is basically like, who knows what list slicing is? List slicing, you can have a list. 1, 2, 3. Wow. I actually type at my job, so. List slicing means I can take like, what's the third item? I can take the 1 to 3 item, from 1 to 3. iSlice lets you do that on iterators. So
It's a wrapper to run calling next.
yep,
A fixed amount of time.
a bunch of times. Yep, that's exactly right. I think what this does. So this takes the first 3. You can also skip the first 3 and go to the end. I guess it skips the first 2. Oh, that's the first 3. So yeah, it's basically a wrapper around calling next a bunch of times. But it works with intervals is the point. So it's order, one memory basically. And what else is fun here? Take while is kind of cool. It lets you keep eating from the iterator until a certain condition is met. So it's basically a while loop, but for iterators. So you can say like take while. This is my classic. Oh, let's do lesson 5. So it just eats from the iterator until the condition is false, and then it stops. So it's while loops for iterators. So that's really cool. You can also write things like drop while, which means it drops them until it hits the. But you'd have to write that yourself. It's not here. Now zip is actually really useful. So if you have 2 iterators, and then let's see here. This will zip them together. So you have 2 iterators. It takes from the first. Well, you'll just see. So we have 2 iterators, range to 10, and we have doubles of range to 10. And it takes the first of each, puts them in a tuple, takes the second of each, puts them in a tuple, so the third of each, puts them in a tuple. See how it does that? And you can actually zip, you can do 3 tuples, 4 tuples. You can zip a bunch of things together. That's why it's called zip. It's like a zipper. It takes the 2 sides and connects them, connects them, connects them, connects them. So zip is pretty cool.
Did you say drop while? It's there.
Oh, drop while is here?
Yeah.
They must have added it recently. By recently, like last 10 years. Wasn't here last time I've been using it, but yeah.
I did it in my country.
Yeah, whoops. Yeah, so, I mean, these are really cool tools. You can look through these. Obviously, a lot more, like, you can do all the permutations of a particular list. Anyways, there's a bunch of tools, and there's libraries. There's like Iteratools Extras or something that has a bunch more of these. But the point is, we can use these to build loops compositionally. So we can build big loops out of small loops, effectively building pipelines. We can do some really interesting things. So, yeah, as my magic example, which involves both T and zip, I actually wrote the. Where is it? I probably removed it because it was just too pains. Yeah, here it is. This uses something extremely trippy. This is an iterator that I wrote that consumes from itself. It's a recursive iterator that eats its own tail. So this is a Fibonacci sequence, but it yields the first 3 elements of the Fibonacci sequence. Then it tees itself, so it creates 2 copies of itself. It advances the right side by 1, so the right side is now offset by 1. And then it yields from the addition of the zip of those 2, basically giving you the sum of the last 2 for every new item. So it gives you the Fibonacci sequence, but it uses order n, gives you order n for performance. So I mean, if you want to see it works, it does actually work.
You mean order one.
What's that?
It doesn't use order n memory, it uses order one.
Well, it doesn't use, yeah, it uses order 1 memory, but it uses order n steps to get the answer. The naive answer is like order 2 to the n, I think. Order, let's see, notes. So yeah, so this is my fib bar. The naive implementation of fibs would take like a year to calculate that. This calculates it instantly. There is actually a much more Pythonic way to write this. I pasted it in here somewhere. Here it is. Here's a generator that generates all the Fibonacci numbers. So you can see it starts with 2 variables, 0 and 1, and then while true yields the left one, and then it basically, that weird syntax is basically shifting them over by 1 and summing them. So
Well,
this,
that's equivalent to what you did, or no?
oh, they both have the same answer, yeah. They're both Fibonacci, and they both order n to get the answer.
Okay.
This is just way more Pythonic. But the one I did is, this is like a iterative generator. The one I wrote is technically a co-recursive one, so it's just
Oh, I see.
a little more trippy for fun. What are some other interesting things in here? Yeah. So, any other questions? Would you like me to implement something? Other than that, I'm done. Just wanted to.
Will these be posted?
What's that?
Will these be posted online somewhere?
The code?
Yes.
I could post it, yeah. Right now, it's just a bunch of functions in a file, but yeah, I'll post it. I'll post it with the talk. Any other thoughts, comments? Great. I'll be around if you have questions. Thanks a lot.